Okay, in this video we're doing Calc AB Problem Set 105. The problems and playlist are in the description below. Let's see what the problems are. Number 1, the average value of f of x equals ax squared plus b on the interval from -2 to 4 is 20, while the average rate of change on the interval is 4. We want to find the values of a and b. Okay, so we're combining those two ideas that are sometimes confused. Average value is integral over interval, so I'm going to set that up. Our integral from -2 to 4, f of x dx over 4 minus -2, integral over interval is 20. So that's 6, so 120. And then we're just going to integrate. We're going to reverse the power rule all the way through. So we get 1/3 ax cubed plus bx from -2 to 4, and that should be 120. So we got to plug in here. So we're going to get 1/3 a, 4 cubed is 64, plus 4b minus quantity. 1/3 a -2 cubed is -8, and then plus -2 times b, which is -2b, equals 120. Got to collect some things here. So we have 64 over 3a, and then we also have plus 8 over 3a, which is 72 over 3, which is 24 a's. Then we have 4b plus 2b, so we have 6 b's, and that's going to equal 120. Can divide everything by 6 because we're probably going to have to solve a system of equations, so we want everything as simple as possible to begin with. So we get 4a plus b is equal to 20. That's one equation. We're going to get another equation from average rate of change, which is algebra 1 slope. So average rate of change, algebra 1 slope, f of 4 minus f of -2 over 4 minus -2 is 4. So f of 4 minus f of -2 is 24. F of 4 is going to be 16a plus b. F of -2 is going to be 4a plus b, and then that equals 24. So this gives us just 12a is 24. So it is a system, but it's like a simple system to solve. So a is 2, and if a is 2, then we get 8 plus b is 20, so b is going to be 12. So those are our values of a and b. So I thought it would be a 2x2 system. I mean, it is a 2x2 system, but like a simple one that you can solve by substitution. All right, next up. Evaluate. So two of the classics that we've seen. We haven't seen maybe we haven't seen the integral of the absolute value of x minus 1 in a while, but both of these should just be done graphically. So I'm going to graph absolute value of x over x. You want to be super familiar with that graph just so you can blow through that problem if it shows up. Both of these are they have a chance of showing up as a multiple choice question. And because of that, I want you to be super ready for that, not waste any time on it, just get the answer and move on. This part B you should also do using a graph. The only relevant points are the endpoints, which are 0 and 4, the endpoints of the integral, the bounds of the integral, 0 to 4, and the vertex, which is at x equals 1. Those are the only points that we really need to know. So at 0, you get 1, at 1, you get 0, and at 4, you get 3. I'm going to draw two triangles, and I'm going to add up the areas of those triangles. So half of a 1 by 1 is 0.5, half of a 3 by 3 is 4.5. Add those together, we get 5. Straightforward, way more challenging if you don't exactly know how to do it and you start trying to find the antiderivative of the absolute value of x minus 1. It's just a lot of work. You can still do it. You have to write the absolute value of x minus 1 in a piecewise fashion and integrate each branch. It's not a nightmare, but it's not great. All right, next problem. Evaluate the derivative of the integral from 1, is that 1? Yeah, 1 to, might be time to get my eyes checked, sine of x squared, square root of t cubed plus 5. All right, second fundamental theorem. So we're going to take the upper bound and sub it in everywhere we see a t in the integrand. So that's going to be the square root of sine cubed of x squared plus 5. And then times the derivative of the upper bound. So the derivative of this, the derivative of sine is going to be cosine of that thing times the derivative of that thing, which is 2x. And then I think the more normal way to write this would be 2x cosine of x squared and then the radical. But honestly, the previous step was just as good. All right, let's take a look at the last problem in this problem set. Write the equation of the line tangent to f of x equals secant squared of 3x at x equals pi over 12. All right, so we need to know the value of the function. So we need f of pi over 12. F of pi over 12 is going to be the secant squared of pi over 4, because pi over 12 times 3 is pi over 4. Cosine of pi over 4 is root 2 over 2, so that means secant is... So it's better actually to think of it as 1 over root 2 when you think of it that way, because that makes secant just root 2. and then we just have to square root 2. So 2 is definitely f of pi over 12. We're going to need the derivative, so f prime. This is a chain rule problem, so it's going to be 2 times the thing. The derivative of secant is secant tan, and then the derivative of 3x is 3. So we get this. We have to plug pi over 12 into this, which is like not as bad as it could be. I mean, things could always be worse, right? So we got a 2 and a 3, so that's 6. You're going to have, there's a secant and a secant, so you get secant squared of 3 times pi over 12, so secant squared of pi over 4. We just figured out secant squared of pi over 4 was equal to 2, though, right? And then tan of pi over 4. Tan of pi over 4 is 1. It's like the best of the tangents. So this is really just 6 times 2 times 1, which is 12. And then we write our tangent line in point slope form. This is a pretty good problem set. So y minus 2 equals 12, quantity x minus pi over 12. There you go. I hope this was helpful, and good luck.